All right, let's dive right in. We're talking about a discovery that is just wild. Imagine finding a galaxy that's almost completely invisible. It's a ghost, really, hiding out in one of the most violent places in the entire universe. And finding it, well, it changes pretty much everything. So that leads to the big question, right? How on earth do you find a galaxy that's 99.99% invisible? I mean, when something barely gives off any light, all the usual methods just go right out the window. So how did astronomers even know where to begin looking? To answer that, we've got to visit the scene of the crime. Okay, so our whole mystery here unfolds about 300 million light years away in the Perseus galaxy cluster. And let me tell you, this is not a quiet cosmic neighborhood. Think of it more like a chaotic, swirling metropolis with hundreds of galaxies all bound together by this immense gravity. And in a place like this, galaxies can get, well, mugged. Yeah, mugged. And the process is called ram pressure stripping. Now, picture this. A galaxy is just hurtling through the superheated gas inside this cluster at insane speeds. That gas acts like a cosmic hurricane, and it just violently rips away all the fuel the galaxy needs to make new stars. It basically just extinguishes it, leaving behind this dark stellar skeleton. And the Perseus cluster? It's the perfect storm for this to happen. We're talking one of the most massive objects we know of, just swimming in gas heated to tens of millions of degrees. It's basically a cosmic demolition derby, the absolute perfect laboratory to go looking for a galaxy that's had its lights punched out. So knowing a ghost could exist in a place like this is one thing, but actually finding it, that's a whole other ballgame. You can't just look for starlight, it's not there. So scientists had to get really clever and come up with a totally new technique. They decided to hunt for the only things that might have survived this whole stripping process. And that brings us to these things, globular clusters. Just think of them as these ancient, super dense balls of stars, almost like little glittering beacons. And here's the key idea, the real aha moment. Even if the galaxy itself is too faint to see, its globular clusters might still be orbiting its invisible core. So the method they came up with was this brilliant three-step plan. First, they used the Hubble telescope to map out every single globular cluster they could find. Then, they ran a statistical model that flagged this one tiny area where 4 of these clusters were just impossibly close together. I mean, the odds were astronomical. And finally, they pointed 2 of the most powerful telescopes right at that spot. And bam, there it was. A faint, ghostly glow. They had found it. So, what did they call this ghost? Officially, it's Candidate Dark Galaxy 2, or CDG2 for short. And believe me, what they found out about its composition, it is absolutely mind-blowing. Just look at that number, 99.99%. Based on the way it's behaving gravitationally, scientists figure that up to 99.99% of this galaxy's entire mass is dark matter. You know, that mysterious stuff that holds the universe together but we can't see? Yeah, this galaxy is made almost entirely of that. I mean, look at this. It really shows you how extreme this is. All the stuff we normally see, the stars, the gas, that makes up just a tiny, tiny fraction of 1% of its total mass. It's basically a giant clump of dark matter with just a faint dusting of stars inside. And if you want to understand just how incredibly faint this thing is, check this out. Our own galaxy, the Milky Way, shines with the light of about 10 billion suns. CDG2, it's putting out the light of only about 6 million suns. It's just a flicker, a whisper in the cosmic dark. And just when you think it can't get any weirder, it does. The galaxy's stars are spread so incredibly thin that its own little satellite objects, those 4 globular clusters they found, actually contribute up to 1/3 of its total light. Can you imagine that? It's like the moons of a planet being way brighter than the planet itself. It's just bizarre. So, okay, finding one super weird ghost galaxy is cool, for sure. But why does it really matter for the bigger picture? Well, it's because CDG2 gives us a massive clue to a puzzle that's been bugging astronomers for a long, long time. And that puzzle is known as the missing satellites problem. See, our best model of the universe, it's called Lambda CDM. It predicts that big galaxies like ours should be surrounded by thousands of smaller dark matter halos. But when we actually look out there, we see way, way fewer little dwarf galaxies than the theory says there should be. So where's everything? Well, CDG2 offers this incredibly elegant solution. What if the satellites aren't missing at all? What if they're just invisible? What if they're dark matter halos that got their star-forming gas ripped away before they ever had a chance to really light up? They're cosmic ghosts, and they've been hiding from us this whole time. So you can see why this discovery is such a huge deal. It gives a big boost to our standard model of the universe. It shows us how tough these little globular clusters are, and maybe most importantly, it proves we have a brand new way to map out the invisible architecture that holds the whole cosmos together.
I just love this quote because it really gets to the heart of it. This ghost galaxy isn't just some weird object. It's a tracer. It's like finding a few glowing rivets on a giant invisible skyscraper that's been standing there the entire time, and now we can finally start to see its shape.
And that really leaves us with this huge, profound question to think about. Discoveries like this prove that our view of the universe has been seriously incomplete. I mean, if the very skeleton of the cosmos is made of this invisible stuff, how much else is out there that we've totally missed just because we didn't know how to look for it?